Welcome to the Char Chit Chat, a podcast exploring all things biochar related, coming to you from a small sheep and tree farm in the deep south of New Zealand. This episode is an audio version of a new article on the Biochar Network New Zealand's website. This is one of the literature reviews that has been recently completed. It is titled Biochar Makes Better Milk and More of It. It outlines 10 beneficial attributes of biochar for dairy farms. The point of this research was to look at the current academic research shows and come up with, a feasible list of benefits to encourage dairy farmers and other ruminant livestock farmers to start to use biochar in their farming operations. The dairy farm industry was targeted because it is probably the most easy from a practical point of view, the easy way to add biochar into the feed ration that the cows normally eat while milking. 50 grams, 100 grams, 150 grams of biochar into that feed and mix it up. And anecdotal and evidence shows that that has been pretty straightforward for farmers. There's a couple of really important studies that are used in this literature review. That's a study in Western Australia and another study in South Australia where dairy farmers used it for the whole milking season and had really, really good results. Anyhow, I will start reading through it. I am skipping past the bracketed reference to the academic paper, but all of that is in the full form on the BNNZ website, where you can see all the full references, and most of them have links to where that information has come from, where you can find it on the internet. Basically, every sentence or every second sentence in this document has a reference to an academic paper. Okay, so since 2010, biochar has been used as an input in animal farming. Several studies have documented livestock and soil health improvement with the use of biochar as a feed supplement. Improvements in the animal immune system, digestibility, quality of milk, both higher protein and higher fat, and quality of meat have been evidenced, as well as the elimination of toxins. The application to soil of animal manure mixed with porous biochar also offers multiple benefits, both agronomic and economic, by providing plants with essential nutrients and reducing nutrient leaching from the soil. Biochar is an ideal input into dairy systems because of many benefits to the whole system itself. An outline of a number of positive benefits that enhance the efficiency and product yield, as well as mitigating some of the negative environmental effects that arise in commercial dairy farms, follow shortly. Paybacks can be as short as 7 weeks. The addition of biochar at rates of 0.8% to 1% of dry matter intake per cow per day can lead to improvements in the following areas. Number 1, improved weight gain. Biochar supplementation confers several benefits to ruminant health and productivity. It has been shown to reduce scouring in young animals and improve nutrient absorption. A significant body of research indicates that biochar enhances rumen fermentation patterns. It often increases the concentration of total volatile fatty acids, particularly propionate, which is a more energetically efficient energy source for the animal compared to acetate and butyrate. This shift in the volatile fatty acid profile is consistent with the observed reduction in methane, and it indicates improved energy harvest from feed. Improvements in rumen health and function translate to tangible productivity gains. Biochar feed supplements enhanced average daily gain and feed efficiency in growing beef and lamb animals. The supplementation also appears to improve nitrogen utilization, reducing nitrogen excretion in urine and potentially lowering ammonia emissions from manure. Positive correlation of methane-reducing factors with increased feed conversion efficiencies were noted in field trials on dairy cattle. Number 2, more milk and better. Another beneficial effect of feeding biochar to animals is due to its redox activity as a geobattery or a geoconductor that accepts, stores, and mediates electrons from microbial biochemical reactions. This electron shuttling capability, which is linked to its production temperature, low temperature biochar acts as a battery, high temperature biochar acts as a conductor, helps overcome metabolic redox limitations in the anaerobic gastrointestinal tract, potentially leading to more energy efficient digestion and higher feed efficiency. I found this very interesting. So, to say that again in my own words, feeding biochar to the animal, the biochar is going into the gut and basically acting as a battery where it can take electrons from a piece of grass. So say there's a calcium atom there in the grass that the animal wants to absorb. In that chemistry, in the breakdown of the food, sometimes those atoms need to gain an electron or lose an electron to become available to the animal. So that's how I see it, as a battery. So it's giving electrons and sometimes it's storing them and sometimes it's taking them. Okay, second paragraph. Despite limited scientific studies, widespread European farmer and veterinary practice indicates that feeding biochar to cattle improves overall health, increases vitality and weight gain, enhances milk quality. For example, there is a lower somatic cell count, and it also reduces issues like diarrhea, hoof problems, and veterinary costs overall. One promising study in South Australia resulted in milk yield increases of at least 2% and a definite positive return on investment in the cost of purchasing biochar for each cow and farm income by a minimum of 6%. Okay, so it's basically just saying that the milk yield increase by itself was enough to pay for the char. And the milk yield, that study actually used other farms as the control so that the milk yield being influenced by seasonal variations, that was factored into the end calculation, the end result. Okay, and the last point is that powdered activated carbon supplementation, so feeding activated carbon in a powdered form, also had a significant increase in milk protein by over 2%, and milk fat was significantly increased to an average of 6%. This is another study. Now, the difference is that activated carbon isn't actually the same as biochar. It's made in a more industrial process. The main difference at the end result is that it's got a much higher surface area, normally around double. And so we can use this, we've included this in the literature review because it just means that you need to use about double biochar to get the same surface area. So if you feed more biochar instead of less activated carbon, the results should be more or less the same. Okay, so that was the second point, more milk and better. Third point is higher fertility. So the general consensus currently in the academic literature is that biochar can improve overall animal health and digestive performance, which indirectly supports better reproductive outcomes. Biochar has been and still is used because of its high adsorption capacity for a variety of different toxins like mycotoxins, plant toxins, pesticides, as well as toxic metabolites and pathogens. Adsorption therapy, which uses activated biochar as a non-digestible sorbent, is considered one of the most important ways of preventing harmful or fatal effects of orally ingested toxins. The therapeutic use of charcoal as a feed supplement and prophylactic to absorb toxins and prevent or treat diarrhea and infectious diseases in livestock was a known and recommended practice among German veterinarians in the early 20th century. So that research goes back to 1936. A charcoal sauerkraut juice combination and humic acids led to the improved health of Holstein cows in Europe, challenged by glyphosate in GMO feeds accompanied by some with chronic botulism. Okay, so that research is 2013, 2014, where there were cows getting botulism from contaminated feed. There's GMOs in Europe. There's, widespread glyphosate use, and that glyphosate does end up in livestock. And so it was found that, a charcoal sauerkraut juice, so the sauerkraut's a probiotic with lots of good bacteria, and the charcoal is holding on to that. And so putting that into the animals really helped those cows recover quite quickly. Okay, so that was higher fertility. So basically saying that higher fertility comes from animals being much, much more healthy, having regular biochar. Number 4 is lower methane emissions. This was probably the most difficult one to give proof of, because a lot of the studies are done in a lab, in vitro, and it's very difficult to measure the methane coming out of an animal that's walking around a paddock or in a shed. They have various methods of doing it, but it's not so reliable, and it's also very expensive. So we do have some study, and they've been included, but the overall results have only been around 10% improvement, which in New Zealand we have 4.7 million dairy cows, and a 10% decrease in methane would be great for greenhouse gas warming. But it's actually a lot better than that, because the production of the methane in the rumen is actually kind of a waste of energy. So these paragraphs kind of highlight that. So if the animal is actually more efficiently converting the feed into energy and the feed into meat and milk, well, that's really a huge win for farmers. They don't need so much grass or so much other feed. Okay, so here we go. The primary mechanism by which biochar suppresses methanogenesis is believed to be its impact on the rumen ecosystem, particularly through its porous structure and surface functionality. Biochar's extensive surface area and complex pore network provide a habitat for microbial colonization, including bacteria that compete with the methogenic archaea for metabolic hydrogen. Hydrogen is a key substrate for methanogenesis, and its diversion towards alternative metabolic pathways, such as reductive acidogenesis or sulfidogenesis, can directly reduce methane production. In vitro studies have demonstrated that biochar can facilitate hydrogen transfer and act as an electron shuttle, promoting these alternative hydrogen sinks. The functionality of biochar is a crucial determinant of its anti-methogenic potential. So in order to enhance the performance of high surface area biochars produced at higher temperatures, their functionality may also be increased through techniques such as addition of mineral salts, metallic oxides, or clays to the feedstocks before or after pyrolysis. And this is kind of known as designer chars, where you can add things in before you cook the wood and bake all the volatiles out of it, or after it's been made, you can also add certain things to it, and it changes the qualities of the biochar. While in vitro results are consistently promising, evidence from in vivo trials is more variable, though generally positive. Dosage of biochar appears to be a critical factor. So wood biochar is used at an average rate of 1 8.2% of DMI yielded methane reductions of 8.8 to 12.9% in controlled feeding. But this is yet to be verified in grazing. Okay, so if I do a quick summary of that, I did in the beginning say a little bit, but there is some quite technical language there. Again, at the biological and chemistry level, down to actual atoms and what's happening there, it gets very complicated and is quite difficult for people that aren't actually in that science to really understand. The biochar is acting kind of like as a battery for the hydrogen. Okay, point number 5, less drenching and better health. In vitro and in vivo experiments with bovine calves showed that biochar, especially in combination with wood vinegar, was able to control parasitic protozoan Cryptosporidium parvum infection and to stop diarrhea of calves within 1 day. The number of oocysts in the feces dropped significantly after a single day of feeding biochar, and after 5 days, no more oocysts could be found in the feces of calves. Now, I don't know if I'm pronouncing that word correctly or not, but basically the eggs in the feces, I think it's eggs, or an egg-like structure, disappeared after 5 days. So it's basically clearing up those particular parasites. Since 1915, research into activated biochar has revealed its effect in reducing and adsorbing pathogenic clostridial toxins from Clostridium tetani and Clostridium botulinum. So your tetanus and your botulism. So that was from 1915. Herbicides are also bound to biochar in the gastrointestinal tract, especially glyphosate, which is known to cause changes in the gastrointestinal microbiota. It has been shown that glyphosate is kind of like a sterilizer. It's killing indiscriminately. It's killing bacteria and fungi. And so it's no surprise that if that goes into the gut, it's going to change that combination because some bacteria and fungi will be more sensitive to it than others, and some will get killed and some others won't. So it's changing the whole balance of the gut biome. Okay, but yeah, there wasn't a lot of references there directly for the drenching, but there is a lot of anecdotal evidence around. And if you talk to livestock farmers who are using biochar, quite often they are not using drenches or significantly less drenches than they normally do for parasites. Number 6, improved pasture recovery and soil health. A Western Australian farm trial involving feeding biochar to cattle, where there were known dung beetle activity, concluded that strategy was effective in improving soil properties and increasing returns to the farmer. It was also concluded that the biochar absorbed nutrients from the cow's gut and from the dung. Dung beetles could transport this nutrient-rich biochar into the soil profile. There was little evidence that the recalcitrant component of the biochar was reduced through reactions inside the gut or on or in the soil. Okay, so that's quite a large quote from the main researcher there in 2015. Unfortunately, there was not a follow-up paper published from that particular farm trial. It would be nice to see what the longer-term effects of the biochar being put into the soil by the dung beetles has been. I have actually emailed that farmer and asked him a whole array of questions, so hopefully he will get back to me, and then I will update. If there's anything to update on the website, I will update the article. I'm hoping that he has continued to feed biochar every year since the trial because of the obvious benefits, so we'll see. We'll see if he's making his own or buying it and whether it's cost effective for him to do that or not. Second paragraph of improved pasture and recovery and soil health. During its passage through the digestion system of the cattle, biochar seems to capture organic and mineral compounds with high plant fertilizing properties. Most of these captured plant nutrients, especially nitrogen and phosphorus, remained bound in the porous structure of the biochar until its incorporation into the soil, where they are likely become to a large extent plant available, as has also been found for biochar after aerobic composting. Okay, so multiple benefits there. That trial in Western Australia was kind of documenting dung beetles taking it into the soil. New Zealand does have some dung beetles, but probably more earthworms and compost worms. So I suspect that they would be breaking down the manure and incorporating that manure and some of that biochar into the soil profile. Okay, number 7, nutrient retention and leaching reduction. Biochar and biology-rich systems can be created to treat agricultural runoff. These reduce the nitrogen in dairy wastewater by 91%, as well as reduce nitric oxide concentrations, and can be used to recover lost nutrients such as phosphate. The associated cost of recovering nutrients has reduced in recent years. Biochar mended vegetated filter strips for the treatment of nitrates in silage bunker runoff areas also reduce nitrogen leaching and loss to the atmosphere. Biochar filters can also recover lost nutrients and reduce fertilizer costs. Biochar can be added to slurry before pasture application and has the potential to reduce total gaseous losses. Moreover, farmers reported that adding 0.1% biochar in a liquid manure pit reduced odors, surface crust, and nutrient losses. Okay. So this is not for the benefit of the animal itself, but more to do with the farm as a system. And I mean, there's been a lot of negativity towards dairy farmers and leaching of nutrients from those farms affecting the local waterways and so on. So this filtering system where we put biochar in some kind of filter, preferably a living filter, a reed bed or something like that, where the biochar is the main substrate, then you grow reeds and other water-loving plants in that. When the runoff passes through that, the biochar catches onto the nutrients, the plants start sucking that up and putting that into their bodies, and it doesn't then go off the farm and into the local waterways or down into the groundwater. We can set up these biology-rich systems anywhere that can be identified on a farm where there's significant nutrient excesses. So near the manure pits that might overflow when it's really wet, or around the silage bunkers, these kinds of things, yeah. Number 8, wintering barn bedding benefits. Biochar applied to bedding, which could be hay, wood chips, straw, sawdust, and so on, at 5 to 10% by volume, acts as a sorbent for both gases and animal excrement, capturing nitrogen from leaching or volatilizing, as well as reducing hoof disease and odors. Modifying the pH of biochar greatly improves its capacity as a bedding material. Urolytic bacteria, which convert urea into ammonia, are most effective in conditions around pH 8.5 to 9. Incorporating fresh char into animal bedding also increases the quality of biochar by inoculating the surfaces and pores with nutrients and microbes. These improved biochars can then be applied to agricultural soils, improving soil health and climate resilience, or even better, can be added to a composting process. That composting process is a link to the other literature review that was done about biochar being added to composting processes, and again, another list of 10 benefits to that composting process. Okay, so yeah, that one's pretty simple. Add biochar into the bedding and you get a lot less ammonia smell. It's better for the animal health, makes them more comfortable. Number 9, manure composting improved. So biochar adds air, it retains moisture, speeds up composting, adds microbe habitat, it adds alarming effect, it reduces the leaching away from the composting, it decreases the associated greenhouse gas emissions, and biochar production with manure as a feedstock results in a very high macronutrient availability compared with other biochars. Okay, so number 9 was just a quick summary. Hopefully there are dairy farmers and other livestock farmers who are making their own compost. So if they are, well then adding biochar in the bedding is adding that into that manure composting process. Okay, maybe they don't have a wintering barn, so then maybe they can just add the biochar to their manures that they then compost, and they'll get all of these other benefits. Lastly, number 10, anaerobic digestion or biogas enhancement. So again, some dairy farms around the world are using now small-scale biogas. So all the wastewater that washes out the milking yards, all of that can be put into a biogas digester, and then the methane from that can be used to generate electricity or heat something like a greenhouse and so on. Heat the water for the use in the dairy shed would be a pretty obvious benefit. Okay, so biochar has been shown to increase the methane production in biogas digesters and decrease gas impurities. A recent review concluded that additions of biochar improve the efficiency of anaerobic digestion by improving conditions for microorganisms and enzymes responsible for biogas production. Okay, so that's quite a short one. All right, and then after those 10 points, there's a little bit of further information where we've added some really good supporting resources. There's one article titled The Use of Biochar in Animal Feeding, which was made in 2019, and it's a really, really good summary of all the research up until 2019. And then there's a few others. There's a review of mechanisms controlling soil and plant responses to biochar. Quite a nice meta-analysis done in 2021. There's a 2022 article called Can Biochar Improve the Sustainability of Animal Production? And it looks at all the key benefits of biochar. And then I've also listed the anecdotal and case study evidence from a biochar dairy trial. Now, there wasn't an academic paper resulting from this one, but there was a report done, and it was also looking at milk yield and quality, and it showed that there was increases in both of those. It was also looking at the soil carbon and soil minerals in the soil as a result, also to do with dung beetles. So there's a full report of that with a link. Okay, so at the bottom of the document on the website, there are a list of all the references. This literature review has used 38 references to back up those 10 points. And if you have got something from this literature review, if you're going to use biochar and feed it to your livestock and get benefit from it, the Biochar Network would really appreciate you to become a member or to make a donation. Your donations will help to fund our organization and to fund this kind of research compilation. This research took around 30 to 35 hours, and we would like to do many more of these literature reviews to show that biochar can be used in other things. Other topics might include the composites, so putting char into other products such as making a building material and having biochar in the walls of the building. It can be used in concrete, in tarmac for roads. Then there is biochar being used with tree crops, so in orchards and vineyards. There is biochar being used in horticulture, in grain production, and treating wastewater. So, all the small towns have sewage plants. So biochar can be used as a filtration device in that, but also pyrolysis can be used for the sewage sludge. Biochar could be used in the nursery industry as a input into the potting mixes, and there's probably many other functions. I probably missed a few, but there's lots of different things, lots of different industries that biochar could be beneficial to. All right, well, I hope you enjoy the audio version of Biochar Makes Better Milk and more of it. And thank you for listening. Bye for now.